All right, here with A&P. This is some information about equilibrium, okay? So just right off the bat, the first thing to know about equilibrium is equilibrium is not really something that we think about consciously, okay? We only notice equilibrium changing when we are moving around, okay? If we're in constant velocity, we're not really gonna notice any changes in our equilibrium. But if we are in constant acceleration, then we're gonna notice, okay, something's going on, right? Our heads are gonna notice, okay, we got some equilibrium changes going on. And we're gonna show you how those active potentials are sent to the brain. So first thing first, we gotta go over the anatomy. So we have the semicircular canals here, and then we have the cochlea here. We're gonna focus on the canals and the vestibule. So, in the vestibule, you have the utricle and you have the saccule. The utricle is responsible for detecting horizontal movements. The saccule is responsible for detecting vertical movements. And these are just some facts about the utricle and saccule. The utricle and saccule are inside the vestibule. So again, they're inside of this vestibule structure. And the little hairs that are on top of the little hairs that are in the utricle and the saccule are on top of what's called ampulla. And that also applies to the crista ampullaris, which we'll get to in a second. The utricle and the saccule, they detect acceleration, not constant velocity. Okay, so if I'm running this way, my utricle is going to detect those horizontal movements. Okay, so if I'm running this way, that means that the utricle is deflecting the other way because of inertia, right? Remember the law of inertia, object in motion like to stay in motion. Well, if I'm running this way, then my utricle cells are going to deflect the opposite way. If I jump up in the air, then that's vertical movement, so my saccule cells are going to deflect downward, in this case, like this, which is going to tell me that I'm having constant acceleration in vertical movement. But if I'm just driving on a highway, my utricle is not going to pick that up because it's constant velocity. If I'm speeding up, then my utricle will pick it up and it'll deflect in the opposite direction because of inertia. And the utricle and the saccule will detect linear movements, okay? Linear movements in plane X and plane Y, just like you see here. For rotational movement, that's where these semicircular canals, so this stuff here, comes into play. Inside these semicircular canals, we have what's called a cupula. And the cupula also has hair cells in it, and these hair cells are called crista ampullaris. The crista ampullaris are also on top of ampulla. So when we rotate like this, our endolymph is going to flow, and that endolymph is going to deflect the cupula. When the cupula is deflected, it's going to, the hair cells are going to hit the top of it, and that means that they're going to open up their tip lengths, depolarize, send action potentials down through cranial nerve 8 to the brain. And the endolymph also applies to the utricle and the saccule. When we are moving linearly, it's the endolymph that's going to deflect the utricle and the saccule as well. So that's just a little bit more information about the equilibrium pathways.